is Lakshmi, working as assistant professor in the Department of ECE at SNS. So today I'm here to discuss about the lecture series on case study on the industrial sensor networks using Zigbee protocol. So we all know that the industrial environments require continuous monitoring of parameters like temperature, pressure, humidity, vibration, gas concentration, and meshing status. So the traditional wired monitoring system, they involve high installation cost, complex maintenance, and limited flexibility. So the wireless sensor networks, which is based on Zigbee technology, provide a low cost, low power, and reliable alternative solution for industrial monitoring. So here, this case study presents the implementation of industrial sensor network using the Zigbee technology for real-time monitoring of the manufacturing equipment and environmental conditions. So, the Zigbee for industrial sensor networks. So a medium-scale manufacturing plant experience certain problems like frequent machine failures, difficulty in monitoring the equipment located in the remote areas, high maintenance cost due to the wired communication system, delayed fault detection, and lack of centralized monitoring. So the management decided to implement Zigbee-based wireless sensor network, so which would improve the operational efficiency. So the main objective was to monitor the industrial parameters continuously, reduce wiring and maintenance cost, enable real-time data transmission, improve the machine reliability. So let us discuss how this model works. So before that, so the agenda for the today's case study here is the problem, industrial connectivity problem, so which we have discussed now. Then the Zigbee protocol and stack architecture, the mesh topology and the deployment, and how this RF coexistence and interference affects the system, and also the field results and the summary. So the connectivity problem, so wiring cost dominated budget. So equipment is mobile or rotating and the dense RF environment. So existing this Wi-Fi infrastructure, motor drivers and the metal structures share or it will disrupt the 2.4 gigahertz band, that is radio frequency band. And then the other parameter is the power, that is the battery life requirements. So why we go for Zigbee? So the Zigbee, as we have discussed, it has good low power consumption, good battery life, and the node density is around thousands, and the installation cost is low, and the throughput is 250 kbps, kilobyte per second. So when we compare this with other Wi-Fi, wired, and the Bluetooth technology, Zigbee plays a major role in its low cost and low power uh, system. So the Zigbee protocol stack. So how this works? So here the layer are physical MAC security network and the application layer. So the system architecture consists of the sensor nodes. So we have the various parameters to be monitored. Accordingly, we use temperature, humidity, vibration, gas, and other sensors, and the microcontroller and the transmitter. So the router nodes extend the communication coverage and relay the information between the sensor nodes and the coordinator. And the Zigbee coordinator will collect the data from all the sensor nodes and sends it to the monitoring computer. And the monitoring station will control the sensor reading, alarm notification, and gives the maintenance report. So the working principle here is basically the sensors continuously measure the industrial parameters. The microcontroller process the sensor data and the Zigbee modules transmit the information wirelessly. The router nodes forward the data to the coordinator and the coordinator will send the data to the monitoring system. So the operators in turn receives the alerts if abnormal conditions occur. So as the topology on which this Zigbee work is based on the mesh topology. So Zigbee coordinator and the sensor box. So based on this, it works. So the RF coexistence here is the Zigbee shares the spectrum with Wi-Fi and other ISM band devices. So the RF coexistence in 2.4 gigahertz band. So the distance, it will dominate the neighbor RF. Channel planning matters the most. So operating on the channels 15, 20, 25 or 26, that is non-overlapping with the common Wi-Fi 20 megahertz channel. So this will cut the drop rate by 3 to 8x in our trial. So security architecture. So this enables security features like authentication, trust center authorization, then the network key shared by all the nodes, which is used for encryption and decryption. Then the link key, that is per device pair, end-to-end encryption between two specific devices, and frame counters and replay the protection. So the summary here is the strong fit for dense low rate battery powered sensing means we can go for this Zigbee protocol, which is based on mesh topology, self healing, and multi year battery life solved the core problem of the industry. And this RF discipline is also not negotiable, it is not optional, and security is a deployment practice, it is not just the protocol feature. Thank you.